Hello everyone, how are you? Today we're gonna explain bisectors in triangles. If we have three or more lines intersecting like that, this is called concurrent. And the point of intersections of these lines the same as point of concurrency, the same meaning. We studied before the perpendicular bisectors theorem in the previous lesson. And we said the perpendicular bisectors of a triangle, they intersecting at a point equidistant from the vertices. The same as this theorem, but today we will explain the concurrency, the point of intersections of these perpendicular bisectors. Here, by looking at this triangle ABC, we have three perpendicular bisectors, PX, PY, and PZ. They intersecting at the point P. This point P is equidistant, the same distance from the vertices of this triangle. That means PA equal PB equal PC. Here, the point of intersections of these perpendicular bisectors, this is called the circumcenter. Then circumcenter of the triangle is the point of concurrency or the point of intersections of the perpendicular bisectors. Since we have circumcenter is equidistant, the same distance from the point of intersection and the vertices, PA equal PB equal PC, then we can use this circumcenter as the center of the circle that contains the vertices A, B, and C. And we can say that circle is circumscribed about the triangle. The circumcenter of a triangle, the point of intersections of the perpendicular bisectors, it can be inside the triangle like the acute, on the hypotenuse of the right triangle, or outside the triangle like the obtuse triangle. How to find the circumcenter of the triangle? As we explained before, the perpendicular bisector is the segment passing through the midpoint and making a right angle. Then to find the circumcenter of the perpendicular bisectors or the point of intersection of the perpendicular bisectors, we need to find the midpoint of each side and draw perpendicular passing through each midpoint. Here we have vertices given in this problem like this triangle POS. Let's graph the points. Point P 06, then the point P is here 06. O is the origin, this one. S is 40, then here by graphing this triangle we have, as you see here, we have right triangle. Then we can find the point of intersection or the circumcenter, as we explained it in the previous slide, that the point of intersection or the circumcenter, it would be the midpoint of the hypotenuse. They will intersect at the hypotenuse. Then let's find the midpoint of PO, the midpoint of OS. After that we will draw the perpendiculars of the two sides PO and OS, and let's see where is the circumcenter or the point of intersections. Let's find the midpoint of the side PO. We can use our formula x1 plus x2 over 2, y1 plus y2 over 2, or we can count the distance from P to O and find the midpoint. Then by applying this formula or by counting the distance from P to O, we will find that the midpoint of PO is here 03. By the same way, we can find the midpoint of the side OS, and we will find that the midpoint here, this point, by drawing the perpendiculars to these two sides perpendicular bisectors like that, we will get that the midpoint here, as we said, the circumcenter of the right triangle here on the hypotenuse. Then the circumcenter, the coordinate of the circumcenter is 2, 3. By the same way, we will solve this problem. Here we have the given vertices of the triangle ABC. Let's graph each point. After graphing the 3 points of the triangle and drawing this triangle, by the same way, let's find the midpoint of the horizontal side, this side, and the vertical side. The midpoint of the horizontal is here, and the midpoint of the vertical is here. By drawing the two perpendicular bisectors, then we will get this point of intersection, this circumcenter, because we have right triangle. Then the circumcenter, the coordinate of the circumcenter is 6, 5. What about the angle bisectors theorem? The concurrency of angle bisectors, the point of intersection of the angle bisectors. By looking at this triangle ABC, here the angle bisectors like AP, BP, and CP, they intersecting at a point P. Then the point of intersection here, the point P, is equidistant from the sides. That means PX equal PY equal PZ. This point of intersection is called the incenter of the triangle. This is the point of concurrency or the point of intersections of the angle bisector of our triangle. By looking at this diagram, the point X, Y, and Z are equidistant from the point P, the point of intersections. Then the center of the triangle ABC, the point P, is the center of circle. This circle inscribed in the triangle, not like the previous one circumscribed about the triangle. No, this is inscribed, drawn inside the triangle. Let's solve this problem, identifying and using the incenter, the point of intersections of the angle bisectors. By looking at this triangle ABC, we have three angle bisectors. Like AG, this is angle bisector, BG, and CG. And the point of intersections of the three angle bisectors, or the incenter G, is equidistant from the sides. That means GE equal GD equal GF. By using the given GE equal 2x minus 7, GF equal x plus 4, let's find GD. Since the three distances are the same, they equidistant, they have the same length, then by using the equation that GE equal GF, then we will make substitution 2x minus 7 equal x plus 4, because the distance are equal, the same. Then by solving this equation, we will get that x equal 11. Let's make substitution in any equation, because all of them the same. Then GF equal x plus 4, or 11 plus 4 equal 15. Then the length of GD, the same as GE, the same as GF, equal 15. Let's solve this question. Here we have the triangle and the given length of the distance from the point of intersections of the angle bisectors Q. Then QN equal QO equal QM. To find the length of QO according to the given, we will make substitution, because QN equal QM equal QO. Then here 5x plus 36 equal 2x plus 51. By solving this equation, we will get that 3x equal 15, then x equal 5. Then let's make substitution by using the variable x that equal 5 in any equation like that, 5x plus 36, we will get that the length of QO equal 25 plus 36 equal 61. Thank you for listening and have a nice day.